Good morning, everybody. Welcome to our third day of virtual learning, your fifth day. So you've made it through the week, and hopefully you're all doing pretty well. So what I thought we would do today is go a little bit of a blast from the past. So the last two classes you guys worked on, solving a system of linear equations by graphing. So you had two linear equations, and then you put them into a graph, or you put them into a computer that did the graph for you, and it plugged out an x coordinate, an x number, and a y number, and that was the solution to both equations. It was the one point that was common to both equations. We're now going to move on to solving it, instead of by graphing, by this concept known as substitution. So when we do that, we're going to need to remember how to solve for a variable. So what we're going to do is we're going to go back to what we did in the first chapter. Okay, so it's just a little bit of a refresher lesson for you guys on how do you solve for a variable. So that way, when we go to solving by substitution, you'll be much better set up. So the first equation is 3x plus 15 equals 24. So we want to know what x is. Now, we don't know what x is. We know that when you take x and you multiply it by 3, then you add 15 to it, you get 24. So we need to find x. So if you think about the rules of order of operations, PEMDAS, remember those. Okay, you do what's in parentheses first. Then you do exponents, which we don't have. Then you do multiplication and division first, and then addition and subtraction. So the first thing I would do to x is multiply it by 3 and then add 15. So if I want to know what x is, I got to take it apart. Oops, I don't know why that happened. Take it apart backwards. Okay, so the first thing we're going to do is subtract our 15 from both sides. You guys remember that if you do to one side, you have to do it to the other side of the equal sign. Otherwise, it does not remain equal. So 3x plus 15 minus 15 is just simply 3x. And 24 minus 15 is 9. So now I know that a number times 3 gives me 9. So how do I undo this multiplication? I undo it with division. I just do the opposite operation. So 3x divided by 3 is just x, because that's 1x, because 3 divided by 3 is 1. 9 divided by 3 is 3. So my answer here is 3. So x is 3. So when x is 3, this equation is true, because 3 times 3 is 9. 9 plus 15 is 24. Now let's come over to this one, which is a little bit more complicated, but again, not terrible. So what's different here is we have parentheses, and in parentheses we have an equation, x plus 2. Now what am I doing to x plus 2? Well, these parentheses tell me to do what's first, but if I can't do anything else, it also tells me that I am multiplying. So I'm multiplying this whole thing times negative 3. And then I add 5x to it, and what am I left with? I'm left with negative 9. So how do we simplify this? Well, if you remember, we're going to use a process called the distributive property. Now, you did this when you first started multiplying, when you did 3 times 12, right? You do 3 times 10, and then you add to that 3 times 2, and 3 times 10 is 30, 3 times 2 is 6, so 3 times 12 would be 36. We're doing the same thing, it's just that instead of this being a 10, it's just an x. And this is a negative 3. So negative 3 times x is negative 3x. Negative 3x times 2 is negative 6. I didn't do anything to my 5x, so I just rewrite it. And that still equals negative 9. Okay, so now we have to combine our like terms. So like terms are anything that have the same variable. Technically to the same power, but we're not really there yet. So anything that's a variable or no variable at all. So negative 3x plus 5x are common, so that's going to be 2x. Sorry, I'm going a little quick because I'm running out of time. Minus 6 equals negative 9. Well, this looks very similar over there. I have 2x minus 6 equals 9, so what I have to do is I have to take things apart. So if I'm adding or subtracting to a variable, I need to get rid of that.